Welcome to Career Campus Pro YouTube channel. My name is Kiran Baburaj. In this video, we will learn about the basic operations of a table. A table is a container for storing data in an organized way. It is similar to a spreadsheet. It has rows and columns that help structure information. The key difference is that in databases, you need to define the structure before you can store any data. This organization makes your information clear and incredibly easy to find later. Let's move on to the basic syntax for creating a table. As you can see, the commands start with the create table followed by your table name. Inside the parentheses, you will define each column with its name, data type, and any constraints. Here is a simple example, a user table with 3 columns ID, name, and age. Each column definition is separated by a comma, and the last of the line we put a semicolon. Table constraints are the rules that keep your data clean and organized. The primary key constraint makes a column both unique and required, perfect for IDs. And the foreign key connects the tables together, connecting relationships between different data sets. And unique constraint ensure all values in a column are different from each other. Not null means a column must have a value. And check constraint lets you to create custom rules for what values are acceptable. Let's see these constraints in action with a product table. We are using serial primary key again for our ID column, and the name column has a not null constraint because every product needs a name. And price we use decimal with 2 parameters, total digits and decimal places. And finally a boolean to track whether the product is in stock. One of the most powerful feature of a relational database is connecting tables together. Here we are creating an orders table that links to our product table. The foreign key constraint creates these relationships, connecting the product ID on our orders table to the ID column in our products table. These relationships ensures the data integrity, and you can't create an order for a product that doesn't exist. We use the references keyword followed by the table name and the field name to reference. Always use clear and descriptive table name that reflect the data they contain, and keep the name simple and consistent across the database. Plan the table structure before you start coding, and start with minimal design and add complexity as needed later. And always choose the most appropriate data type for each column to save space and improve the performance. Here are some of the common mistakes to avoid. Don't forget to include a primary key. Tables without them are hard to work with. And avoid spaces in tables and column names. Use underscore instead, and never store calculations inside the table. And avoid duplicating the data across multiple tables. And don't use the wrong data type. So what happens when your perfectly designed database need to change? We have the alter command. This is a powerful command that lets you modify the existing table structures without losing the data. We can add or remove columns as the application evolves. We can change the column types when we need different data formats, and add or remove the constraints to maintain the data integrity, and even rename the tables or columns to keep the database organization clear and consistent. Moving on to some basic alter commands. For adding a column, it's straightforward. Just specify the column name and data type. The syntax is alter table, table name, add column, column name, data type, semicolon. And to remove a column, alter table, table name, drop column, column name. That's all. And to rename, similarly, alter table, table name, rename to column name. Now let's see how to modify the existing columns. To rename a column, use the rename column command with the old and new names. And to change the column's data type, alter column command with type lets you to convert the data formats. And to set a default value for new rows, use set default with your desired value. These column modifications help your schema evolve with changing needs. Next, moving on to the constraints. Here we are adding a primary key to an existing table. Perfect when you have created a table without one. The syntax is alter table, table name, add primary key, and within the braces we specify the column. And we can also add a foreign key relationship after the table creation. For that, we use the keyword add constraint. Let's explore adding more constraints. The set not null command ensures a column always contains a value. We use the alter table followed by the table name, then alter column name, then set not null. Sometimes we also need to remove the constraints as the requirement change. The drop constraint command removes a specific constraint when you reference it by name. If a field is not required, you can remove its not null constraint with drop not null command. This operation provides the flexibility to adapt to the database as the application evolves. Congratulations, you have mastered the essential create and alter table commands in SQL. With these skills, you can confidently adapt to the database schema as your application grows and requirements changes. If you found this video helpful, hit the like button and subscribe for more SQL tips and techniques.